Welcome to this comprehensive MCQ explainer on the fundamentals of electrical and electronics engineering. In this video, we will solve 60 key questions from semester examinations, detailing each answer step by step. I am Abhijit De, and I hope this session helps you build a solid foundation for your exams. Let's begin. Question 1. Which component opposes any change in the current flowing through a circuit? Option A. Resistor. Option B. Capacitor. Option C. Inductor. Option D. Diode. The correct answer is C. Inductor. An inductor stores energy in its magnetic field when current flows. According to Lenz's law, any change in current induces a back EMF that opposes that change, resisting variations in the circuit current. Question 2. The duration of one complete cycle of an alternating quantity is known as its Option A. Waveform. Option B. Peak value. Option C. Instantaneous value. Option D. Period. The correct answer is D. Period. The time period is the duration in seconds required for an alternating quantity to complete one full cycle. It is the reciprocal of frequency, meaning a higher frequency results in a shorter period. Question 3. An ideal current source has which of the following internal resistance characteristics? Option A. Zero internal resistance. Option B. Infinite internal resistance. Option C. Low value of voltage. Option D. Large value of current. The correct answer is B. Infinite internal resistance. An ideal current source must deliver a constant current. To prevent internal leakage, its parallel resistance must be infinite, ensuring all current is delivered to the load. Question 4. The C unit of magnetomotive force in a magnetic circuit is Option A. Ampere turn. Option B. Weber. Option C. Mho. Option D. Maxwell. The correct answer is A. Ampere turn. Magnetomotive force is the driving force that establishes magnetic flux. It is calculated as the product of turns and current, giving it the unit of ampere turn. Question 5. The property of a material which opposes the creation of magnetic flux in a core is called Option A. Permeability. Option B. Permittivity. Option C. Reluctance. Option D. Resistance. The correct answer is C. Reluctance. Reluctance is the opposition offered by a magnetic circuit to the passage of magnetic flux, analogous to electrical resistance. It depends on the core length, area, and permeability. Question 6. The energy stored in the magnetic field of an inductor is given by Option A. E equals half Li squared. Option B. E equals half IL squared. Option C. E equals IL squared. Option D. E equals Li squared. The correct answer is A. E equals half Li squared. An inductor stores energy in its magnetic field when current flows. The stored energy is directly proportional to the inductance and the square of the current. Question 7. Eddy current loss in a magnetic core is directly proportional to which parameters? Option A. F squared and B m squared. Option B. F and Bm. Option C. F and Bm squared. Option D. F squared and Bm? The correct answer is A, F squared and Bm squared. Eddy current loss is caused by circulating currents induced in the core. It is proportional to the square of frequency and maximum flux density and is reduced by core laminations. Question 8. The direction of an induced EMF always opposes the change in flux producing it. This is stated by option A, Faraday's first law. Option B, Lenz's law. Option C, Ohm's law. Option D, Ampere's law. The correct answer is B, Lenz's law. Lenz's law is a consequence of the conservation of energy, stating that the direction of the induced EMF always opposes the change in magnetic flux. This is represented by the negative sign in the induction equation. Question 9. What is the C unit of inductive reactance in an alternating current circuit? Option A, Henry. Option B, Farad. Option C, Ohm. Option D, Joule. The correct answer is C, Ohm. Inductive reactance is the opposition offered by an inductor to alternating current. Like resistance, it is measured in ohms, although it does not consume power as heat. Question 10. In a single-phase AC circuit, the expression VI sin theta represents option A, active power. Option B, reactive power. Option C, apparent power. Option D, true power. The correct answer is B, reactive power. The product VI sin theta represents the reactive power which oscillates between the source and the load's reactive fields, measured in volt-amperes reactive. Question 11. When a purely sinusoidal voltage is applied across a pure capacitor, the current in the capacitor, option A, lags the voltage by 90 degrees. Option B, leads the voltage by 90 degrees. Option C, is in phase with the voltage. Option D, is in phase opposition with the voltage. The correct answer is B, leads the voltage by 90 degrees. In a pure capacitor, voltage takes time to build up as charges accumulate, meaning the current leads the voltage by exactly 90 degrees. Question 12. The peak factor for a purely sinusoidal alternating quantity is option A, 1.0. Option B, 1.414. Option C, 1.11. Option D, 2.0. The correct answer is B, 1.414. Peak factor is the ratio of maximum value to RMS value. For a sine wave, this is the square root of 2, which is approximately 1.414. Question 13. If the maximum value of a sinusoidal current wave is 100 A, what is the RMS value of this current? Option A, 70.7 A. Option B, 100 A. Option C, 50 A. Option D, 70.7 Ma. The correct answer is A, 70.7 A. The RMS value of a sine wave is its peak value divided by the square root of 2. For a peak of 100 amperes, this results in 70.7 amperes. Question 14. The voltage per turn in both the primary and secondary windings of an ideal transformer is option A, high in the high voltage winding. Option B, low in the low voltage winding. Option C, identical in both windings. Option D, dependent on the load current? The correct answer is C, identical in both windings. In a transformer, the primary and secondary windings share the same core flux, which means the induced voltage per single turn is exactly the same in both windings. Question 15. A 10 kVA, 1100 over 400 volt, 50 Hz transformer has 100 secondary turns. The number of primary turns is option A, 1000 turns. Option B, 44 turns. Option C, 275 turns. Option D, 110 turns. The correct answer is C, 275 turns. Using the transformer turns ratio formula, the primary turns equal the secondary turns multiplied by the ratio of primary to secondary voltage, which yields 275 turns. Question 16. The direction of mechanical force on the armature conductors of a DC motor is determined by option A, Fleming's left-hand rule. Option B, Fleming's right-hand rule. Option C, right-hand thumb rule. Option D, Lenz's law. The correct answer is A, Fleming's left-hand rule. For motors, Fleming's left-hand rule determines the direction of electromagnetic force, where the thumb represents motion, index represents field, and middle represents current. Question 17. A semiconductor diode is classified as which type of electronic component? Option A, bidirectional device. Option B, unidirectional device. Option C, linear device. Option D, bilateral device. The correct answer is B, unidirectional device. A diode allows current to flow in only one direction under forward bias while blocking it in reverse, which is the definition of a unidirectional device. Question 18. The free electrons in a p-type semiconductor material are classified as option A, majority carriers. Option B, minority carriers. Option C, heavy charge carriers. Option D, stationary ions. The correct answer is B, minority carriers. In p-type semiconductors, trivalent doping creates an abundance of holes as majority carriers, leaving thermally generated free electrons as minority carriers. Question 19. At absolute zero temperature, an intrinsic semiconductor behaves as a option A, conductor. Option B, perfect insulator. Option C, superconductor. Option D, semiconductor. The correct answer is B, perfect insulator. At 0 Kelvin, all covalent bonds are intact and no thermal energy is present to release electrons, leaving the material with zero charge carriers acting as a perfect insulator. Question 20. An ideal operational amplifier has which of the following input and output resistances? Option A, R in equals infinity, R out equals 0. Option B, R in equals 0, R out equals 0. Option C, R in equals infinity, R out equals infinity. Option D, R in equals 0, R out equals infinity. The correct answer is A, R in equals infinity, R out equals 0. An ideal op-amp draws zero current from the source due to infinite input resistance and can drive any load without loss due to zero output resistance. Question 21. The closed-loop voltage gain of an inverting amplifier using an ideal op-amp is option A, AV equals minus RF over RI, option B, AV equals RF over RI, option C, AV equals 1 plus RF over RI, option D, AV equals minus 1 plus RF over RI. The correct answer is A, AV equals minus RF over RI. In an inverting amplifier, the virtual ground at the inverting terminal maintains a simple current balance, making the gain the negative ratio of feedback to input resistance. Question 22. The closed-loop voltage gain of a non-inverting amplifier using an ideal op-amp is option A, AV equals minus RF over RI, option B, AV equals RF over RI, option C, AV equals 1 plus RF over RI, option D, AV equals minus 1 plus RF over RI. The correct answer is C, AV equals 1 plus RF over RI. For a non-inverting amplifier, the input voltage is applied to the positive terminal, and negative feedback sets the voltage gain to 1 plus the ratio of feedback to input resistance. Question 23. Which of the following gates are classified as universal logic gates? Option A, XOR and XNOR. Option B, AND and OR. Option C, NAND and NOR. Option D, NAND and XOR. The correct answer is C, NAND and NOR. These are universal gates because any Boolean logic function can be constructed using only NAND gates or only NOR gates, simplifying integrated circuit designs. Question 24. Which of the following digital electronic circuits is used to store exactly 1 bit of information? Option A, NAND gate. Option B, decoder. Option C, flip-flop. Option D, multiplexer. The correct answer is C, flip-flop. A flip-flop is a bistable circuit that maintains its state indefinitely until triggered, serving as the fundamental building block of registers and digital memory. Question 25. In Boolean algebra, the logical sum of multiple logical products is known as option A, product of sums. Option B, sum of products. Option C, NOR operation. Option D, XOR operation. The correct answer is B, sum of products. In Boolean logic, a product term is an AND gate and a sum is an OR gate. The logical sum of products refers to the SOP expression where AND terms are ORed together. Question 26. A rectifier is an electrical circuit specifically designed to convert option A, DC signal to AC signal. Option B, AC signal to pulsating DC signal. Option C, AC signal to pure DC signal. Option D, DC signal to high-frequency AC. The correct answer is B, AC signal to pulsating DC signal. A rectifier uses diodes to convert bidirectional AC current into a unidirectional, pulsating DC current, which is later smoothed using filters. Question 27. The current through a series RLC circuit under the condition of resonance is equal to option A, V over R, option B, V over XC, option C, V over XL, option D, V over Z where Z is complex. The correct answer is A, V over R. Under resonance, inductive and capacitive reactances cancel each other out, making the circuit purely resistive, which yields a maximum current equal to voltage divided by resistance. Question 28. The commercial capacity ratings of power transformers are expressed in terms of option A, kilowatt. Option B, horsepower. Option C, kilovolt ampere. Option D, kilovar. The correct answer is C, kilovolt ampere. Transformer heating losses depend on voltage and current independently of the power factor, meaning transformers are rated in apparent power using kilovolt amperes. Question 29. Two sinusoidal EMFs are E1 equals A sin omega t plus 45 degrees and E2 equals B sin omega t minus 30 degrees. The phase difference is option A, 15 degrees. Option B, 45 degrees. Option C, 75 degrees. Option D, 30 degrees. The correct answer is C, 75 degrees. The phase difference is the absolute difference between the two angles. 45 minus negative 30 equals 75 degrees. Question 30. When connected across a steady-state DC voltage source, a pure inductor acts as a option A, short circuit. Option B, open circuit. Option C, resistor of value L. Option D, frequency filter. The correct answer is A, short circuit. Direct current has a frequency of 0, which reduces inductive reactance to 0, making a pure inductor act as a short circuit under steady DC conditions. Question 31. The operating magnetic flux in the core of a practical transformer, option A, increases with load. Option B, decreases with load. Option C, remains constant irrespective of load. Option D, oscillates randomly. The correct answer is C, remains constant irrespective of load. Under load, secondary current demagnetization is balanced by an increase in primary current, keeping the core flux constant. Question 32. In an autotransformer, electrical power is transferred from primary to secondary through option A, conduction process only. Option B, induction process only. Option C, both conduction and induction processes. Option D, mutual coupling only. The correct answer is C, both conduction and induction processes. An autotransformer transfers power conductively through the shared electrical tap and inductively via self-induction in the single winding. Question 33. The number of flip-flops required to construct a decade counter is option A, 2, option B, 3, option C, 4, option D, 10. The correct answer is C, 4. A decade counter has 10 states. To count up to 10, we need n flip-flops such that 2 to the power of n is at least 10. 4 flip-flops are required since 3 can only count up to 8. Question 34. The maximum possible number of states in a ripple counter built with 5 flip-flops is option A, 32. Option B, 15. Option C, 10. Option D, 5. The correct answer is A, 32. A ripple counter with 5 flip-flops can count through 2 to the 5th power, which equals 32 distinct states from 0 to 31. Question 35. A wire of resistance 16 ohms is bent to form a circle. The effective resistance across any diameter is option A 32 ohms, option B 16 ohms, option C 8 ohms, option D 4 ohms. The correct answer is D 4 ohms. Bending the wire divides it into two parallel halves of 8 ohms each. The parallel combination of these two halves across the diameter results in 4 ohms. Question 36. What is the C unit of magnetic reluctance in a magnetic circuit? Option A. Ampere turn per Weber. Option B. Ampere turn per meter. Option C. Ampere turn. Option D. Newton per Weber. The correct answer is A. Ampere turn per Weber. Reluctance is defined as magnetomotive force divided by flux, yielding the unit of ampere turn per Weber. Question 37. If a 110-volt supply is applied across a light bulb rated for 220 volts and 100 watts, the power consumed is option A. 100 watts. Option B. 50 watts. Option C. 25 watts. Option D. 12.5 watts. The correct answer is C. 25 watts. Power is proportional to the square of the voltage. Since the applied voltage is half of the rated voltage, the consumed power drops to 1/4 of 100 watts, which is 25 watts. Question 38. A current of 10 amperes enters a parallel combination of two resistors of 2 ohms and 3 ohms. The currents are option A, 4A and 6A, option B, 6A and 4A, option C, 2A and 8A, option D, 5A and 5A. The correct answer is B, 6A and 4A. Using the current divider rule, the current through the 2 ohm resistor is 6 amperes and through the 3 ohm resistor is 4 amperes. Question 39. A magnetic circuit requires 800 A. The 100-turn coil has 5 ohms resistance. The applied voltage must be option A, 40 volts. Option B, 20 volts. Option C, 10 volts. Option D, 5 volts. The correct answer is A, 40 volts. MMF equals turns times current, which gives 8 amperes. By Ohm's law, 8 amperes times 5 ohms resistance requires an applied voltage of 40 volts. Question 40. If the supply frequency of an AC system increases, the inductive reactance of a coil will option A, decrease. Option B, increase. Option C, remain unchanged. Option D, become zero. The correct answer is B, increase. Inductive reactance is directly proportional to frequency as shown by the formula XL equals to pi FL. Therefore, an increase in frequency increases the reactance. Question 41. Which DC motor is widely preferred for electric traction applications? Option A, DC shunt motor. Option B, DC series motor. Option C, DC compound motor. Option D, separately excited DC motor. The correct answer is B, DC series motor. DC series motors deliver high starting torque because torque scales with the square of armature current, which is ideal for heavy traction loads like trains. Question 42. The potential barrier across a PN junction diode is established due to option A. Majority carriers. Option B. Minority carriers. Option C. Recombination. Option D. Immobile donor and acceptor ions in the depletion region. The correct answer is D. Immobile donor and acceptor ions. Diffusion of carriers leaves behind positive and negative immobile ions on either side of the junction, establishing the potential barrier. Question 43. In a common emitter configuration, a bipolar junction transistor behaves as a option A. Voltage-controlled voltage source. Option B. Current-controlled voltage source. Option C. Voltage-controlled current source. Option D. Current-controlled current source. The correct answer is D. Current-controlled current source. In C configuration, the input base current controls the output collector current, making it act as a current-controlled current source. Question 44. The common mode rejection ratio of a practical operational amplifier should be option A. As large as possible. Option B. Close to zero. Option C. Close to unity. Option D. As small as possible. The correct answer is A. As large as possible. CMRR measures the rejection of common noise relative to signal amplification and should be as large as possible to keep noise low. Question 45. Tying together both inputs of a two-input NOR gate results in a circuit that acts as a option A. NOT gate. Option B. OR gate. Option C. NAND gate. Option D. XNOR gate. The correct answer is A. NOT gate. Shorting both inputs of a NOR gate makes the output equal to the negation of the single input, transforming it into a NOT gate. Question 46. A staircase light bulb is controlled by two switches. The switching logic resembles option A. An AND gate. Option B. An OR gate. Option C. An XOR gate. Option D. A NAND gate. The correct answer is C. An XOR gate. The bulb is toggled on when the switches are in different positions, which matches the behavior of an exclusive OR logic gate. Question 47. A field effect transistor is fundamentally classified as a option A. Current-controlled device. Option B. Voltage-controlled device. Option C. Power-controlled device. Option D. Resistor-controlled device. The correct answer is B. Voltage-controlled device. In FETs, the gate voltage creates an electric field that controls current flow through the channel while drawing negligible input current. Question 48. Transformer cores are built using thin laminated steel sheets primarily to reduce option A. Copper loss. Option B. Hysteresis loss. Option C. Eddy current loss. Option D. Friction loss. The correct answer is C. Eddy current loss. Core laminations divide the magnetic path into thin insulated sheets, which limits eddy current loops and minimizes heating losses. Question 49. The total number of PN junctions in an NPN bipolar junction transistor is option A. 1, option B. 2, option C. 3, option D. 4. The correct answer is B. 2. An NPN BJT has emitter, base, and collector regions, which form two junctions, the emitter-base junction and the collector-base junction. Question 50. Electrical conductance in an electric circuit is analogous to which magnetic parameter? Option A. Reluctance. Option B. Permeability. Option C. Permeance. Option D. MMF. The correct answer is C. Permeance. Conductance is the ease of current flow, and permeance is the ease of flux establishment, making them analogous parameters in electric and magnetic circuits. Question 51. The majority charge carriers in an N-type semiconductor material are option A. Holes. Option B. Free electrons. Option C. Valence electrons. Option D. Protons. The correct answer is B. Free electrons. In N-type semiconductors, pentavalent doping adds extra free electrons which act as majority carriers, while holes are minority carriers. Question 52. Weber is the standard C unit used for measuring which physical quantity? Option A. Magnetic field intensity. Option B. Magnetic flux density. Option C. Magnetic flux. Option D. Reluctance. The correct answer is C. Magnetic flux. The Weber is the SI unit of total magnetic flux. Magnetic flux density is measured in Webers per square meter, also known as Tesla. Question 53. A capacitor stores electrical energy in which of the following forms? Option A. Magnetic field. Option B. Electromagnetic field. Option C. Electrostatic field. Option D. Chemical energy. The correct answer is C. Electrostatic field. A capacitor stores energy in the electrostatic field created between its charged plates when a voltage is applied. Question 54. The time constant of a series resistor capacitor circuit is calculated as option A. R over C, option B. C over R, option C. R times C, option D. 1 over R times C. The correct answer is C. R times C. The time constant represents the rate of charging or discharging in an RC circuit and is calculated as the product of resistance and capacitance. Question 55. If two capacitors of 10 microfarads and 15 microfarads are connected in parallel, the equivalent capacitance is option A. 6 microfarads. Option B. 25 microfarads. Option C. 1.5 microfarads. Option D. 5 microfarads. The correct answer is B. 25 microfarads. In parallel, capacitors simply add up, meaning the total capacitance is 10 plus 15, which is 25 microfarads. Question 56. The output of a digital AND gate will be high if and only if option A. Any one input is high. Option B. Both inputs are low. Option C. Both inputs are high. Option D. Any one input is low. The correct answer is C. Both inputs are high. An AND gate performs logical multiplication, which means the output is logic 1 only when both inputs are logic 1. Question 57. The abbreviation TTL in digital electronics stands for which logic circuit technology? Option A. Transistor logic. Option B, thermistor transistor logic. Option C, transfer transistor logic. Option D, tri-state transistor logic. The correct answer is A, transistor logic. TTL refers to transistor logic, a widely used bipolar logic circuit family known for its speed and noise margins. Question 58. An electric motor is an electromechanical machine designed to convert option A, mechanical energy to electrical energy. Option B, electrical energy to mechanical energy. Option C, heat energy to mechanical energy. Option D, alternating current to direct current. The correct answer is B, electrical energy to mechanical energy. An electric motor converts electrical energy into rotational mechanical energy, working on electromagnetic principles. Question 59. In a JFET, increasing the reverse bias voltage applied to the gate will cause the channel width to option A, increase. Option B, decrease. Option C, remain constant. Option D, expand rapidly. The correct answer is B, decrease. Increasing the gate reverse bias voltage widens the depletion regions, which constricts and decreases the width of the conducting channel. Question 60. An ideal voltage source has which of the following internal resistance characteristics? Option A, zero internal resistance. Option B, infinite internal resistance. Option C, zero output voltage. Option D, infinite output current. The correct answer is A, zero internal resistance. An ideal voltage source must maintain a constant voltage under any load, which requires its internal series resistance to be zero.